Hi, I'm Henry Segerman. For the past year and a bit, I have been working with a team of 23 other mathematicians and mathematical artists to create a large multimedia art installation celebrating the creativity and beauty of mathematics. The project is headed by Ingrid Daubechies, a mathematician at Duke University, and Dominique Ehrman, a fiber artist based in Canada. This all started when Ingrid saw Dominique's installation, Time to Break Free, in which a machine of some sort converts flat figures on a quilt into fully three-dimensional characters. This inspired Ingrid to wonder if something like this could similarly bring the beauty and creativity of mathematical ideas to life. Ingrid and Dominique presented at the Joint Mathematics meetings in January 2020, and a group formed around the idea, called Mathamalchemy, which now has 24 mathematicians and artists involved. This is the current 1/4 scale maquette of the piece, a magical island filled with whimsical scenes, made from crochet, knitting, quilting, sewing, weaving, beadwork, needle-felted wool, embroidery, woodworking, ceramics, polymer clay, 3D printing, painting, stained glass, steel welding, acrylic, wire bending, origami, tamari, leather, and light. Whenever a mathematical idea or reference can fit in, we have been fitting it in. The permanent home of the Mathamalchemy installation will be at Duke University, but it will also go on tour, with stops planned at the National Academy of Sciences in Washington, D.C., as well as other international venues, all pending possible disruption due to the pandemic. One of the scenes that I've been involved with is the lighthouse. The top of the lighthouse will have two lights, one projecting horizontally from within a stained glass dodecahedron made by Bronner Butler, and the other projecting up onto the ceiling. This will repurpose an old project of mine illustrating something called stereographic projection. Stereographic projection is a map from the sphere to the plane. So just like the Mercator map is a way of getting the continents of the globe onto a flat piece of paper, stereographic projection is another way to do that. In the model, what's happening is that a light ray starts at the north pole of the sphere. It goes inside the sphere, hits the sphere from the inside somewhere, and then continues on to hit the plane somewhere. And that's the map. It's the light rays do it. Where does the light ray hit the sphere? Where does it hit the plane? You map one to the other. And you can see what stereographic projection does just by looking at the shadow. For example, the triangles in the middle are about the same size as the triangles on the sphere itself, but then as you get further out, they start getting much, much bigger. There are lots of other nice features of stereographic projection to see here. For example, angles are preserved. All of the 90-degree and 60-degree angles and so on the sphere come out as 90 degrees and 60 degrees on the shadow. Also, circles map to circles. There are all of these great circles on the sphere that go to circles on the plane. The shadow is very sensitive to where the light is relative to the sphere, but is not so sensitive to where the table is. So if I move the sphere and the light up away from the table, all that happens is that the shadow scales up. It doesn't otherwise change the image. This is good for us because on the lighthouse, this will be pointing upwards, casting a shadow on the ceiling. And since the installation will be in many different locations, there's no way to know how high the ceiling is going to be. We have a second version planned in case it's necessary. If the ceiling is too high in some venue, then the pattern might get scaled up too much, and most of it get projected onto the walls. The pattern would still be visible, but the shadow on the walls will not have all the nice properties of stereographic projection. Our plan in this case is to use a different repurposed shadow artwork, which projects the Poincare disk model of the hyperbolic plane onto a disk. This pattern only uses a 90-degree cone of light, which will project onto a smaller patch rather than the 180 degrees which is used in the stereographic projection full sphere. Alright, that's the sphere on top of the lighthouse. The plan is that assembly of all of the independently constructed parts of the installation will happen in July of this year, so hopefully more to follow. Thanks for watching.